Hey everybody, in part 6 of the Coin Vault series, I'm going to be going over the cam operations for the Lexan window, or it's also known as polycarbonate. This will be cut on the CNC router because this material cannot be cut on a laser cutter. If you use acrylic, which can be cut on a laser cutter, there's a high chance that this is going to crack when you install the rivets for the window. So, in your cam workspace, you're going to create a setup, new setup right up on the top. That setup is going to be for milling. All the other operations were cutting. This is a milling operation utilizing the CNC router. Your work coordinate system is going to be the top, bottom, left corner. Make sure you have your individual piece, one body for the model selection because we're only machining one thing. In the stock tab, this is going to be a relative size box that's going to have 0.1 100,000ths of material on the outside and no additional material on the top or bottom. So our stock size should be 0.37 by 0.37 by 1/8 of an inch thick. That is the thickness of our Lexan. Post-process tab, program, name or number 1001. It's usually best to give this something. I'm going to do 6 for part 6. And then Lexan 0 for our work coordinate offset number. Click OK. We're going to do this in 2 operations. One operation we're going to cut out the holes, and then the other operation is going to be the profile milling around the outside. So you're going to go to the 2D drop-down menu, and that's going to be 2D contour right here. Since I already have that created, I'm just going to edit my 2D contour. First thing, the tool that you're going to use is going to be that 1/8 inch spiral O-flute, single flute end mill created in a previous video. Link in the description for that video on setting up that spiral O-flute tool just for CNC router cutting aluminum and plastic. For the cutting out of the holes, we're going to be going 18,000 RPM for our spindle speed and ramp spindle speed. Our cutting feed rate is going to be 10 inches a minute. It's a nice little small hole. We don't need to go super fast. Lead in and lead out 10 inches a minute, ramp 10 inches a minute, and our plunge feed rate is going to be 5 inches a minute. The geometry tab, you're going to select the bottom edge of the hole on all 4 holes. On the heights tab, we need to go down to the very bottom and go to the bottom height and make that offset negative 0.03. That is going to drive our tool below the bottom of our stock to make sure that it actually cuts all the way through, and also will kind of account for any variations in Z thickness because of the wood that's on the table or difference in material thickness. We wouldn't want to go any deeper because we don't need to be diving into the table or the spoil board on the router. I'm going to go ahead and turn off all these bodies of these additional items. So we don't need those right now. So up here, I'm going to turn off the bodies for that one, that one, that one, that one, not that one. There we go. Now I'm just focusing on that. The rest of these, as far as the clearance height, the retract height, the feed height, basically our end mill is going to come down in here, and it's going to go slower, and it's going to start feed rating into it. But our bottom height is the most important thing on here. change that to a negative 0.03. If you forget the negative, it's going to be 0.03 above the bottom, and it's definitely not going to cut all the way through the material. On the next tab, passes, there really shouldn't be anything to change in here, but we're just going to look at this 0.0004, 4/10 left in computer. All these should be fine as is. Last tab, linking, basically these should also be fine as is with the default values. There's nothing we should have to change here. Click OK. And that's going to give us a toolpath where we're going to lead in, plunge down, just do a little tiny circular path right here, and then come out and do the next one, the next one, and the next one. And we can see that our tool path is 30 thousandths below the material or the bottom of our stock. You're going to do another 2D contour operation. You can right click this one and duplicate it since it's mostly the same, but it's going to have a little bit of difference to it. This operation is going to still use our 1/8 inch spiral O-flute tool, still at 18,000 RPM, but our cutting feed rate is increased. We're going to cut at 30 inches a minute for our cutting feed rate, our lead in, our lead out, still plunging at 10. And this is for the around the part. Geometry. If you duplicated this original one, you have to deselect by clicking on the X and then reselecting the bottom edge of our part. Making sure that the arrow is on the outside of our part. Because if we have our arrow on the inside, our end mill is going to be on the inside, and we're going to have a part that's going to be 1/4 inch too short. We want to make sure it's on the outside. Also, good indicators that the tabs are on the outside. On that note, we need tabs. Those tabs are going to be 0.125 in width. The tab height is 0.08. At points is going to be the method for determining the placement, and you're just going to put a tab on each side. They don't have to be perfectly centered. They just need to be about in the middle, equally distributed, and those will be ground off with a grinder. On the next tab, just like before, we want to make sure that we're going down deeper than our part to ensure that it cuts all the way through. So that's going to be a negative 0.03 on the bottom height based off of our selected contour. And remember, our selected contour is that bottom edge, which is basically also the same thing as our stock bottom. On the next tab, passes. This should be fine. Left in computer 00, finish feed rate 30. Most of this up here on the top is going to be fine. We're not going to do a roughing pass, but we do need to do multiple depths. We don't want to be too aggressive with our end mill and drop it all the way down and just start doing a full slotting, full width of cut at our 30 inches a minute. We want to actually break it into 2 passes, so we go down about halfway, make a cut, and then go down the other half and make the cut, completing our cut in 2 depths. So check the box for multiple depths. Our maximum roughing step down is going to be 0.08. Our finishing step down is 0. Finishing step downs 0.008. This is the number of step downs. We're not going to have any finishing step downs. You can kind of hover and see a tooltip. 0 degrees. Most of this should be fine. Rough final, even step downs. No stock to leave. Linking tab. This should be just fine. We could do something just to kind of learn a new skill. We can do an entry position. So we're going to change this from entry position right here down at the bottom. And here's our work coordinate system. And we're going to enter right here. So when it goes and cuts out the outside, it's going to go to that middle center. But actually that might not be the best place because we got a tab there. And I think if we go and look at our previous operation, it cuts this hole, this hole, this hole, and this hole. So to save time and machine movement, we're going to actually enter over here, closest to where our last hole operation is. So let me make sure I just have 1 point selecting on the bottom. And then that is it for the 2D contour. Verifying our toolpath, looking for making sure we go past the bottom of our part, and we have 4 tabs, and if I select both of those, we can see our simulation. And turn on the stock, go ahead and turn off the visibility of the model, click play. There's the hole, verifying it's going all the way through, and then there's our outside contour. Just like that. So that is the cam operations for the window using an 1/8 inch end mill, specifically designed for aluminum or plastic with a single flute with 2D contours with tabs. And that's kind of the basics for that machine. When you are ready to cut, you're going to post-process your setup, and under the setup button right here in the upper right hand corner, you're going to go to installed post library. It's going to take a little bit of time for it to load all the 105 posts. In this drop down menu, we need to find the ShopBot ISO. ShopBot ISO. That is the post processor that works the best with the Easy Router. Click post. Save this on your flash drive. I'm going to put this on my desktop. And we can see our G code. 18,000 RPM. And all our coordinates and moving locations for the Lexan window. What else can we see on here? Feed rate of 5. Here's our 2D contour. Feed rate of 10. Plunging down, there's a feed rate of 30. Okay, that is it for part 6 for the, turn the model back on, Lexan window cut on the Easy Router. This process will also be identical if you're going to use the Patriot router. It's a little smaller one. That machine has more of a manual RPM controller, so you have to set that on a knob on the actual router inside the machine, and it uses the FANUC post processor, not the ShopBot ISO, but it's basically the exact same process. That's it.